QSO Today episode 218, Stephen Hicks N5AC. QSO Today thanks ICOM America, makers of the finest HF, VHF, and UHF transceivers for every level of amateur radio operator, and QRP Labs, makers of the QCX single-band transceiver kit, for sponsoring this episode of QSO Today. You can sponsor the QSO Today podcast by supporting these fine sponsors. Welcome to the QSO Today podcast. I'm Eric Guth, 4Z1UG, your host. My QSO today is with Stephen Hicks, N5AC, Vice President of Engineering for Flex Radio. If you have an interest in microwave roving, software-defined radio, especially as it's defined by Flex Radio, and Steve's observations on the state of our amazing hobby, then stay with us to the end. N5AC, this is Eric, 4Z1UG. Are you there, Steve?
Yeah, 4Z1UG, this is N5AC. Howdy.
Howdy. Steve, thanks for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
Yeah, sure. So my dad is a ham. His call's W5TX, and I remember as a small boy, my brother and I used to stay up late at night. We had a stereo in our room, and we would hear him operating sideband, and it would be getting into our stereo. And I remember we would listen to that for a while and then go up and tell him. He had a shack on the top floor of our house. We'd go tell him, hey, we're trying to sleep. Can you keep that down, sort of thing. So from a very early age, I was exposed to it, and we would do field day together. So my dad would take my brother and I out to field day, and we got to see what all that was about. And I was very fascinated by how ham radio worked. And so about I guess I was 12, I got interested in getting my license. And we were in Plano, Texas, and I went to the Plano Amateur Radio Club and took classes there and got my first novice license when I was 12. So that's kind of how things started.
Do you remember your novice call sign?
Yeah, it was WD5EMG. And it was kind of funny because I was watching the call signs come out from other people in the area, in the Dallas area, and watching the letters tick by, and I really wanted EMF real bad for electromotive force, and I missed it by one letter and got EMG. And back then there was you couldn't go online to find out what was happening. There was no online. And so a couple years later I pulled the call book out to see if that guy kept his call, and apparently he let his call lapse, and I was disappointed in that. I think if I had EMF I would have kept it, but I wasn't that nuts about EMG, so when I got my extra, I switched calls.
What year was that when you got your novice license?
78, I think, 77, 78, somewhere around there.
So that kind of places you in a certain time period. What was your first rig?
Well, see, my dad worked for Collins, and so he had a Collins S line, and the first gear that I used, he set up a 75A4, and I think it was a KWS-1, and so those were the first pieces of gear I used, and I was very confused by all of the things that you had to do on them. Like you had to go dip and load and do all this sort of stuff when you transmitted, which people really don't get exposed to anymore that you have with a tube amplifier.
Well, I think there are some people that will say that you started ham radio with an F-16, or the aircraft equivalent of an F-16. How was that user experience for a novice?
It was neat. I wanted to learn how to operate the rig some, but the contacts were very important to me too. So I figured out just enough to make the rig do what I wanted, and then would go work contacts. And I was very excited by the number of people I could work and how all that stuff happened. And I started at an early age being interested in chasing awards. Like I remember the first one that I got was Rag Chewer, and that was a lot of fun.
Did you become a contester after that?
Not really. I liked doing field day and some stuff like that. And then when I got older, I got really interested in microwave and VHF propagation, and did a lot of VHF contesting. I haven't done that in a few years, but for probably 5 or 10 years, I spent quite a bit of time doing that sort of contesting. And I've dabbled in HF contesting. I like doing that. It's just not something that's held my attention. I tend to be kind of scatterbrained and move from thing to thing in the hobby, which is one of the things that's great about ham radio is you can move around and try different things, and if they don't suit you at any particular moment, you can go pick up something else.
Well, that certainly is true today, that there's a huge spectrum of things that ham radio operators can engage in. Were there other mentors or Elmers that helped you along besides your father?
Yeah, the whole gang in the Plano Radio Club was really great to me. I used to go to meetings. We had meetings on Tuesdays or Thursday evenings or whatever, and I would hang out with the kids of other ham radio operators, but also get a chance to talk to some of those people. And early on, there were a few guys that were messing around in Digital Logic, and I really can't remember all their call signs, but the guy that gave me my test directory was K5QY, Dick Sander. But there was WB50HM and several other guys, Joe Blair. I can't remember all the names and calls right now. But a lot of those guys kind of helped me out along the way, and really good guys.
So when you're saying Digital Logic, you're talking AND gates, NAND gates, NOR gates, and OR gates?
Yeah, when I was, I guess, 13, 14, I started messing around with the 7400 series TTL, AND gates, NOR gates, all that kind of stuff, and got really fascinated with it. And one time when I went to one of the local radio club meetings, they would give a door prize away every time. One of them was a little board that had a 7-segment display and some logic on it. And I took that thing home and played with it. In fact, I think some of the guys were disappointed they didn't win it, and they were pretty sure I wasn't going to do anything with it because I was a 13 or 14-year-old kid and I didn't know anything about that stuff. But it really fascinated me, and that really got me started on my career in electronics. Ham radio did. There were a lot of guys in there that I worked with through the years that I was in Plano, and there were guys that showed me about how repeaters worked and a little bit about HF operation, all that sort of stuff. K5AT was one of them. WB5SGN, who's now WS5W. Gerald Jones, W5TU. So lots of guys in that group. I'm sure I'm leaving out hundreds of them. There's a bunch of guys in that group.
Did ham radio play a part in the choices that you made for your education and career?
Yeah, well, like I had mentioned, I got started messing around with electronics a lot as a kid, and at some point my dad also brought a computer home. Well, it started with calculators, programmable calculators, and then computers. And so all growing up, probably from the time I was 12 or 13 up through high school, I did a lot of work with electronics, playing around, making lights blink and that kind of stuff, and writing software on computers. So when I got ready to go to college, I really didn't know which of those two to focus on, and I asked my dad, and he said, you can teach an engineer how to program computers, but it's much harder to teach a computer programmer how to design circuits. And that made sense to me, so I went and started a career in electrical engineering in college to go learn how to do all that. But software was always in the background the whole time, and I did a lot of that in my career later. But really all that stemmed probably from my dad's, who was an engineer, him getting me interested in that and tinkering around with stuff in amateur radio.
Now, did your dad have a pretty decent ham radio workbench?
Yeah, he had a room on the top floor of our house that had it was kind of a hobby room. So there was a pool table in there, but he had a whole wall that had radios in it, and they were all Collins radios for the most part. Now, as I got older, he bought other kinds of radios and played around with other things, and he was really more of a fixer than he is an operator. So he likes to open up radios and fix them for other people and build a station and that sort of thing. And then there was electronics bench as well, where we could solder stuff and play around and that sort of thing.
Where'd you go to school?
Went to Texas A&M for my undergraduate, and then SMU for a graduate degree.
And SMU is where?
SMU's in Dallas. And, it's funny, I had done amateur radio as a kid, and I tried to get my general license when I was, 14 or something, maybe 13, before my novice ran out. And the theory was probably more than I really understood. I looked at the tube stuff, and I was confused by all that. And again, I had the software stuff going on, so I kind of took a break from ham radio in my later high school years. But then when I got to college and started studying engineering, all that stuff just became easy. And in a very short period of time, I went through and got general, advanced, and then extra in college. In the Texas A&M radio club, which I participated in, their call sign, the club call sign was W5AC. And so when I got my extra, I was really interested in having a call that was similar to that. And that's how I ended up with N5AC.
Oh, that's very cool. How did your career evolve as an electrical engineer to where you are today?
Well, like I said, I had a lot of software background as well. And so my first job out of college was with my co-op employer, who was Collins. I'd worked there some through high school and even through college. And what I really wanted to do was to do design work. And there were no electronics design jobs at Rockwell Collins when I started. And so I went to work in the system engineering group. And in that job, we had a product that was a 450 megahertz. It was essentially telephones to farmers. It was people that lived in rural areas, and it was a way to get radio out to them. So I did spectrum planning and that sort of thing to design systems for customers that were going to go in installation. And a lot of it was, like I said, spectrum planning and deciding what equipment to use and where the equipment was going to be seated. And that really didn't interest me as much. And a buddy of mine that had worked in the software field called me at one point and said, "Hey, why don't you come work at Digital Equipment?" Who was I'd used a lot of their computers, DEC computers, in college, and so that really interested me. And I took a leave from electronics into software, and then I spent the majority of my career in software after that. And it was all kind of because I couldn't get a design job initially when I got right out of school. And it's funny, after I had spent most of my career in software, had a company go public, and one of my wife's companies went public, and so had some time off. And I had a bit of this, I had engineering background, but never done any real engineering. And I was doing some contesting, microwave and VHF contesting, and I like to operate out of a rover. And so I had bought a bunch of transverter kits from Down East Microwave and was using those. And in the January VHF contest, I'd be in my rover, and it'd be out in the freezing cold weather. You'd open doors, and the temperature would fluctuate wildly. And because the local oscillators and all the transverters were based on a crystal, they would drift all over the place, and I had a lot of trouble finding people. And so kind of one of my first electronics projects as an engineer happened 20 years after my engineering career, and that was to design an oscillator for my transverters that I could lock to some sort of a reference like GPS and not drift all over the place.
Did it become a commercial product, the oscillator design?
Yeah, it did. For me, it's kind of a necessity, some other invention thing, and I wanted one I could stick in my transverter in place of the crystal oscillator that went right in the same package, because I really like the Down East Microwave transverters a lot. This is just a thing that I wanted to change. And so I designed the oscillator, got it all working, and then went to a Central States VHF conference and presented it. In the back of my mind, I was kind of hoping that people would find it interesting enough that they would want to buy some of them. And I was really hoping that Down East Microwave thought they were neat, because I really I was impressed with what they had done. And so after the presentation, I talked to a couple people. One of them was Steve Costro, into CEI at Down East Microwave. We got to talking about this, and he was expressing interest in putting this in his transverters. The one I initially built was USB programmable, so you would plug it into a computer and use a Windows application to go tell it what frequency you wanted the local oscillator to work on, and it gave you some indications for what kind of phase noise would be with what the frequency you had selected and all that. And Steve said that was way too complicated for most of the people that wanted to use transverters. They just wanted one that would work on a fixed frequency. So I adapted the design some and put jumpers on there. So for whatever band you were on, you could go jumper those. And the other person I talked to at that convention was Gerald Youngblood, K5SDR. And he came up to me and said, he wanted to know what I was doing career-wise. And I said, well, I'm currently in between things, and I'm just doing this as a hobby project. And he said that, he was the CEO of Flex Radio, and that they had bid on some projects to design some receivers for the government. And did I want to come help him? And I said, no, you've confused me with somebody who really understands all this stuff. I said, I'm like a recent college graduate in terms of my electronics understanding, because this is my first kind of project after spending a career in software. And he said, well, I'd still like to talk to you. Why don't you come down to Austin and talk to me? So I thought about it a little, and I said, I'd be in way over my head. I don't want to do that. And so I gave him the names of a few people that I thought might be able to help him out. And he went and talked to some of those people. But in the weeks that passed after I went to that Central States Conference and talked to him, it just kind of sounded more and more interesting to me to be involved in the hobby in a more concrete way. And so I called him up and I said, you know what? I said, I would like to come talk to you about that. So I went down and spent a day with him and the engineering team down there, and which was really one or two other guys. And it sounded like a fun deal. So I ended up taking a job at Flex, and that would have been in, I guess, 2008.
Well, so you're almost a pioneer there. I think Gerald started that company in like 2005 or something?
It was about 5 years before I got started, so I think 2003.
I see. His first product was like the SDR 1000, as I recall from an earlier episode of the QSO Today podcast.
Yeah, that was his first product, and I had run into him one time before at the Austin Summerfest, which is our Hamfest in Austin. And I remember distinctly seeing him, and he had a Flex 5000 there. And if you look at the contrast between an SDR 1000 and a Flex 5000, it's very marked. The 1000 is, it's a series of bare PC boards that are kind of stuck together, and the 5000 is a piece of commercial equipment that has a metal case and heat sinks. It's a real product. And I remember being very impressed seeing that and thinking, gosh, he went straight from that to that kind of thing. But at the time, I was working in software, and it was just a curiosity, and I didn't think anything more of it.
So what are you doing at Flex now?
Well, so we have a larger engineering team now. I've been there about 10 years, and so we've grown quite a bit. And I did end up working on that government project, and we released that project on schedule. It was a year development or something. That was probably some of the hardest work of my life, doing all that and not knowing as much as I really needed to know to do that project. And now we've gone and it's kind of funny, that particular project that we did for the government, they had some specific requirements that led us to some components that we had never used before. One of which is a analog to digital converter for doing direct sampling. And that particular component, we were one of only 3 companies in the world to get to use, because we had a very high-profile project and talked to the vendors about it, and they said, we can give you this unreleased product for you to try out. And so when we started working at that, I did all of the digital logic power supply software for that particular receiver, and Gerald did the RF design. And when he was doing the RF design, Gerald's really focused, and he spent a lot of time thinking about what kind of performance he could get out of the components that we were using, did a lot of simulation and that sort of thing. And he found out that we could get as good a performance out of a direct sampling receiver as you could get out of a narrowband receiver. And nobody really had ever thought about doing that before and thought you could get that kind of performance that I know of. Because even the request that we had gotten from the government to do the project that we did for them consisted of 2 kinds of receivers. One was a narrowband receiver, which the expectation would be much higher performance than a direct sampling receiver, which was used to go find signals of interest that then you would send to the other receiver. And so with that kind of spurred the development of the Flex 6000, because Gerald understood that we could build a direct sampling receiver that had as good or better performance than a narrow receiver could.
And now this message from ICOM America. Heard it, worked it, logged it. October is here and contest season is beginning with QSO parties, school club roundup, sweepstakes in November, and the CQ Worldwide contest also at the end of the month and in November. Now is the time to get the ICOM transceiver that's best suited for your lifestyle. ICOM offers a variety of high-performance and innovative transceivers that fit your ham radio budget. See how you can make the most out of contest season with one of these transceivers. The IC7851 has the competitive edge that you've been looking for and the endorsement by Dr. Ulrich Rohde, N1UL, in episode 208 of the QSO Today podcast as being the best transceiver on the market today. Raise the bar and hear what others cannot hear with this flagship HF 50 MHz transceiver. This is due to ICOM engineers focusing on a new local oscillator design that drastically reduces phase noise. This noise reduction and purity of the LO results in an RMDR of 110 dB, allowing you to hear the extremely weak signals, making the IC7851 the perfect rig for making contacts at the bottom of the sunspot cycle. In addition, this fine rig has a spectrum scope, dual receivers, and a digital voice recorder. The IC7610 is the SDR every ham radio operator wants, and just in time for contest season. This high-performance SDR has the ability to pick out the faintest of signals even in the presence of stronger adjacent signals. The new ICOM 7610 is a direct sampling software-defined radio that will change the world's definition of an SDR transceiver. Its features include RF direct sampling system, 110 RMDR, independent dual receivers, and dual digicell. The IC7300 has changed the way an entry-level HF transceiver is designed. This rig is a high-performance, innovative HF transceiver with compact design which will far exceed your expectations. It includes RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, internal antenna tuner, and an SD memory card slot. No matter which ICOM rig you choose, you'll be a winner. Be sure to check out these fine rigs at www.icomamerica.com, and when you finally go to make your ICOM purchase, be sure to tell the dealer that you heard it here on QSO Today. My thanks to ICOM America for sponsoring the QSO Today podcast. And now back to our QSO. You put up a table in a presentation that you made for CPAC 2018, and that included some chips of various kinds that were in the $150, $300, $600 plus range, up to $12,000. When you mentioned that device you were making for the government, you said that one of those chips was used in that. Which chip was used in that, and how much did that chip cost?
Well, the first device that we did for the government, which is called CDRX, we used a Xilinx Vertex 5 FPGA. FPGA is a field programmable gate array, and it's the simplistic explanation is it's a whole bunch of logic gates that are packed into a part, and you can send some software into it or some bits that tell it how to wire all those up. And the complex explanation is there's a whole lot more in those parts than that nowadays. But that particular part that we used in that first government receiver, I want to say it's a $300-400 part. So in the grand scheme of things, not terribly expensive. We did another project that's an L-band receiver, L-band being 950 to 2150 megahertz, and that one has two Vertex 6 parts in it. It's a XC6 VHX380T is the part, and each one of those parts are about $5,000 a piece.
So you handle those like the crown jewels in the company.
Yeah, they're expensive, and it's got kind of a funny story about that. When I worked on the second project we did, we had a problem when we brought up the first board, and we typically do a deal in electronic design where we design the system, we do a circuit board layout, and then we'll build one or two or three or four of them, and we'll do board bring up where we make sure the board does what we want, we make any changes and all that so that we don't go to production with any problems. And so the first one of those boards that we brought up, there was one line on it, general purpose I/O line that was open and it didn't work. And so, we poked around in software trying to find out what the problem was, and ultimately we decided that it was going to be a hardware problem. So the thing you do on a part like that, the underside of the part has thousands of little balls of solder under it in a grid. And so we x-rayed the part to see those balls of solder and found out that one of them was open. And so we sent the board back to the manufacturer or the assembler who was in Colorado. And, I called them on the phone. I explained the problem. They said, no problem. I said, we need it back really quickly. We're on a tight time frame. And so they said, just send it up here and we'll fix it for you. So I sent it up and then waited a day and expected to get a return shipping notification. Didn't get one. So I called them on the phone and I said, hey, it looks like you didn't ship it. What's the problem? And they said, well, what we had done was we pulled the part off the board and we had told our purchasing group just to go buy another one and stick a new part on the board. We didn't realize how expensive the part was because we had sent them the raw parts and they didn't have to buy them initially. And so they found out it was a $5,000 part, which is more than their assembly even cost, the labor that we paid them to do it. And so they had to rush the chip out to California to be what they call reballed, where they turn the chip up on the upside down and they put new little solder balls on it and then ship the part back. So they were very apologetic about that. They didn't realize how much the part cost either when they built the board.
Well, it's a good thing they didn't throw it in the garbage.
That's right.
Yeah, right. Well, that's very interesting. When you demonstrated that table of FPGAs at the conference, you mentioned that the Flex radios had those Xilinx FPGAs in them. Is that unique in Flex radio design in terms of building transceivers that have some very sophisticated FPGAs in it? And what do you get at? What's the benefit that you get out of that?
Well, the reason that we use that part is if you look at a traditional super heterodyne radio, there will be a series of local oscillators and mixers, and out of the back of that comes an IF that has a certain amount of bandwidth, and you'd feed that IF into, if you wanted to make it a DSP radio, and today you don't really buy any radios that don't have some kind of DSP in them. So you'd feed that into an analog to digital converter, but typically they'd be at the audio range, so they'd be 100 kilohertz wide, or I think in a lot of the ICOM radios they're 36 kilohertz wide. And to go process data at 36 kilohertz, you could do that in a microprocessor, and it's pretty easy to do DSP on it. But what we do in a direct sampling radio is we take an ADC, an analog digital converter, and we sample the entire spectrum. So it might be a whole band, or in the case of HF, the entire HF band. So from 0 to 60 megahertz or something, we'll capture all of the RF data all at once. And that amount of data is just huge. So in a Flex 6000, each individual, what we call signal capture unit, which is a receiver, if you will, generates 4.9 gigabits a second worth of data. So it's a tremendous amount of data. You simply can't process it in a microprocessor. And so what the FPGA does is it's like a mathematical unit where it's custom designed. You can go tell it all the mathematical operations you want it to perform, and it can perform lots and lots of those very fast for you. So we use it to take the HF spectrum, slice out receivers in it, and then feed those to a baseband processor, which does all of the traditional DSP operations like filtering and noise blanking and some of those kind of things. And so those devices are simply required if you build a direct sampling radio. And Flex isn't unique in using those. We're the first commercial ham radio vendor to use those, but they got used early on. At the same time we were doing the project for the government, HPSDR was using those as well. They use a different manufacturer. They use Altera instead of Xilinx. There's a few different manufacturers of those parts. And ICOM now is using those as well. So if you look at either of their direct sampling radios, they also have to have those parts. You just need them to do the kind of stuff that we're doing.
So the benefit to the ham radio operator, at least with this Flex 6000, is that they could actually have up on their screen multiple bands at the same time. So if they're working a contest, for example, and they're on 20 meters and the band is open, they can actually, with their other eye, watch the other bands for opportunities to pounce.
Yeah, that's the real change. If you look at the previous generation of receivers, if you wanted a second receiver, let's say you were a contester and wanted to watch another band or listen to another band, you'd have to use you'd have to completely build another receiver into that radio. In a direct sampling world, because you have all of the HF spectrum at once in the part, you can say, I want to create 1, 2, 3, 4, 8, 10, however many receivers you have the performance to do, and allow the end operator to look at spectrum displays or listen to receivers on as many of those different bands as you want. It's a whole new game.
So on the Flex 6000 then, do you have to have a paired computer with it that actually is doing that grinding?
No, in the 6000 series, we moved all of the computer thinking stuff inside the radio, so you no longer have to have one. Now, we sell two kinds of radios of the Flex 6000. There's the kinds that are really just servers that are a black box, and the front of them of the radio doesn't really have anything on it, maybe a pretty LED or a display, but it doesn't have a spectrum analyzer or anything like that. Those radios, you do have to drive them from something else, but it could be a computer or an iPad or a Mac or anything else. And the computer in that case is used just to show the spectrum and to tune the receiver and listen to the audio and that sort of thing. It's not used for digital signal processing or as an integral part of the radio. The other kind of radio that we sell has a front panel like a traditional radio, so it has a screen and knobs on it and all that, but it has a lot more capability because of the insides of the radio.
In one of the papers that I found online, you talk about Smart SDR. What is Smart SDR, and why is it important to amateur radio?
Well, when Flex did the first SDR 1000, then the Flex 5000, 3000, and 1500, there was an application developed called Power SDR, and it was an open source application which, in conjunction with the radio, performed the radio function. So in the case of those older radios, the radio itself was kind of dumb. It often had a microprocessor in it, but it did no signal processing. All it did was collect the samples and then send the samples off the air to the computer, which did most of the work, the display, everything. So the two of them were an integral pair, and they worked you couldn't use the radio one without the other. Smart SDR, when we looked at that architecture, there were some fundamental problems with it moving forward. One of them was that as you wanted to do more and more things with the radio, you had to pass more and more data between the radio and the computer, and it required a faster and faster and more capable computer. And you could load things on the computer that would interfere with the operation of it. So you might put an antivirus software that would come on and start scanning your computer, and that would cause dropouts or the radio not to work as well. And so we looked at that architecture and said, it really makes sense moving forward to change the architecture and start over from scratch. And so this is a conversation we had in, I don't know, it was 2008 or 9 when we looked at doing the Flex 6000, and we kind of had a real gut-up moment in the company where Gerald and I and everybody talked and said, can we actually go do this? And we were advised by external advisors, venture capitalists, that said, not that we had taken money from, but that were also hams that were friends of the company, that said, don't go change the architecture, you'll lose the company, you'll go bankrupt trying to do something like that. But we looked at it and said, it's really the right thing to do moving forward. And so that's what Smart SDR is. It was a brand new start on software-defined radio that looked at radio in a different way. And the way is, we wanted to have these fungible pieces of things that radio found important: receivers, spectrum analyzers, waterfall displays, decoders for digital modes, all kinds of things, and make each of those a resource and treat the radio more like a server that had things it could offer up to the ham as opposed to just a radio. And so Smart SDR is the realization of that architecture, and it allows you to go say, I want a receiver for this and a receiver for that and a transmitter to do this, and it makes the radio much more flexible than it would have been otherwise.
So it's the fundamental difference between a Flex 6000 and maybe an ICOM 7851.
Yes, it is that and the hardware architecture are fundamentally different.
How much smarter can Smart SDRs get What do you see down the road in terms of capability that we don't have but could have in the future with SDR transceivers?
Well, this is something that's really fascinating to me, and that's one of the things that really interests me in the hobby is that I'm very fascinated by both propagation and I might call it situational awareness, or being able to look around and see what's going on and understand the physical properties of the band and what's happening and that sort of thing. And so there's a lot of additional things we can layer on top of what a radio already does. We could, for example, while your radio is off, we could watch the spectrum and get an idea for what's going on in the world around you and let you know in advance, hey, the bands look like they're about to open, or we see some things from this part of the world. We could decode all kinds of signals to give you a better idea for what's going on. So just dreaming off the top of my head, we could show somebody a map, and if we watched CW signals and decoded all the ones that we saw all across the bands, we could draw you a real-time map that showed not just from a world perspective, but from your perspective with your antennas, what parts of the world you could hear at any given moment. And because the Smart SDR is a internet-enabled application, we could send you a text message and say, hey, we know you've been looking at trying to reach this particular country. All of a sudden now we see signals from that country coming in through your antennas. Not just that those guys are on the air, but we know you can hear them. So there's things like that we could do. You could build in more and more digital decoding into the radio. There's all kinds of things. There's no end to the things that we could do.
What is microwave roving? You mentioned it earlier that you're a microwave rover. Well, what is microwave roving?
Well, every year there's contests that are sponsored from the ARL and other organizations. Some of them are the microwave organizations. And, of course, microwave's anything, what it'd be 900 megahertz or above. And so on a typical VHF contest, let's take September VHF contest or January VHF sweepstakes, you'd operate 6 meters and 222 and 2 meters and 432. But if you look, there's also microwave contests that occur that let you operate on all the bands above that. So 900, 1296, 2304, 3456, 5760, 10 gig, blah, blah, blah. And so because propagation is a real interest of mine, I really have enjoyed doing that sort of work. So what I did, I guess the last time I did a lot of this was in the 2001 to 2008 kind of time frame when I had some time to do things and I wasn't working for Flex, and I would built up a rover that had all of those bands in it. So I had antennas for each of those bands and transmitting and receiving equipment. On the transmitters, many of them I had what would be considered high power. And so during a microwave contest, you don't just get points for working another country or another state. You get them for working grid squares, which is a subdivision of the latitude and longitude maps. And so I would drive in a rover from grid to grid, and each time you enter a new grid, it's essentially a new contest for the rover. He can work everybody he's worked all over again. And because it's microwave, as you drive further and further away from people, the challenge goes up, and you have to find new ways to work people, and pointing your antennas is harder, and you might use interesting propagation techniques like rain scatter or snow scatter or something else to work people. So I found all that extremely interesting.
And now this message from QRP Labs. After watching a video interview with Hans Summers, G0UPL, owner and chief designer of QRP Labs and its fine array of kit products for ham radio, at the 2018 YOTA Summer event in South Africa, I am convinced that QRP Labs will be one of the most exciting ham radio electronic kit destinations this year. In the video, Hans describes his approach to transceiver design, starting with his original Ultimate 3S and the yet unnamed single-band, single-sideband transceiver that will sell for under $100 US. For everyone out there that believes that you have to spend the big bucks to get into amateur radio, you should know that you can build a high-performance rig today with a kit from QRP Labs. What I have learned from doing over 200 QSO Today interviews is that the novice experience where you built your own rig and operated it to make contacts is the most satisfying first ham radio experience. Hans' kits are extremely well documented and supported by Hans and his community on the QRP Labs website. It just takes a soldering iron, some basic electronic tools, and some time to build the QCX transceiver kit for under $50 to get on the air. This full-featured kit has its own test equipment built in to allow you to align and set up this rig. All of the QRP Lab products can be enhanced with additional boards and accessories to allow you to build more rig as you gain experience. If you are a new ham, or an old ham that wants a new amateur radio experience, or even want to repeat your novice experience with the latest technology, then click on the link in this week's show notes page and give QRP Labs a visit. QRP Labs is my favorite kit company. It should be yours too. And now back to my QSO Today. Could you also do meteor scatter or moon bounce with a rover?
Sure, you can. And moon mounts is probably a little more difficult because you have to have a dish that's large enough to do an EME contact. And I don't really know what the minimum size dish is. I guess if the guys on the other end of the contact have really large dishes, you could need smaller ones. But the number of guys that have extremely large dishes are small. And so size really does matter in an EME contact. So if you really want to do a lot of that, you'd probably end up pulling a trailer behind you with a large dish on it. So I've not done any EME other than going to somebody else's house that's an avid EMEer, like WB5LUA, who was an early mentor of mine in microwave work, does a lot of EME work and holds a number of records in that. And so Al, I've been to Al's place before and made an EME contact at his place. And I find it interesting. I'd probably like to try it someday, but I've not done a lot of it. Meteor scatter I have done. And meteor scatter, if you've never done it, is really a lot of fun. On 6 meters, if you have a decent antenna and some power, let's say 100 to 400 watts, you can work people almost any time of the day on meteor scatter. And what happens in this propagation mode is everything from small dust particles to meters will hit the Earth's atmosphere and often bounce off or disintegrate. But when they do that, it creates an ionization trail in the ionosphere, and signals for a brief period of time will bounce off of that. And you can work people 500 to 1,500 miles away in a propagation mode like that. And the typical mechanism for meteor scatter, for folks that don't know, is you would set up a transmitter that would transmit for 30 seconds or a minute, and it would repeat the same message over and over again once every half second or second or something like that. And the guy on the other end of the contact just listens, and all of a sudden a meteor or dust particle or whatever hits the upper atmosphere, and the signal will just show up with S9 plus kind of signal out of the noise, and then it will rapidly fade off, and it'll only last for, depending on the amount of ionization, it might be a few hundred milliseconds to a second or two, and then it goes away. And in that moment, because the signal repeats itself over and over, you'll get all the information that you would to start a contact, the other guy's call sign, your call sign, whatever, and then you tell your transmitter to send the other kind of stuff back and forth. And so you'd work that contact back and forth. And each one of them takes, on a good day, you can work a meteor scatter contact. I guess it takes, been a while since I've done it, but 3 minutes or something to work one. And one time I drove from Dallas-Fort Worth to Orlando, Florida, and ran meteor scatter with 2 guys the entire way. And I worked both guys in every single grid I crossed, except for each one of them I didn't work in one grid because they got up to go eat lunch or something. So it's reliable enough that you can operate with that kind of certainty on meteor scatter.
Now, would you operate the digital modes in microwave roving now?
I have not done a lot of that. The most common mode I use for microwave roving is CW, because you have such a advantage. You have a 20 dB or so advantage over sideband. Now, if signals are good, we would go switch to other modes. So a kind of typical thing to do on microwave roving is you would have a liaison frequency, which would be on 2 meters, and you'd be talking to guys, and you'd say, hey, do you have 5 gig or 10 gig or 3 gig or whatever other band? And they'd say, yeah, I do. And you'd say, okay, meet me over there. And in each one of those bands, there's a calling frequency. So like on 10 gig, it's 10.368.1. And on 3 gig, it's 3456.1. So you'd go over to the calling frequency, and a typical thing to do would be to send dashes. And so you'd you'd take your paddle and just lay on the dash side. So you'd send da, 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 da while you're listening on 2 meters. And the guy'd come up and say, yeah, I hear your dashes. I found you. Go ahead and call me. And he'd set aside his 2-meter radio, and you'd call him, and then you'd work the contact in CW. And if things are particularly strong, you might switch to sideband and work them in sideband, or if they're really strong, work them in FM for fun.
If you're working microwave roving and you're 10 gigs and above, what's the best distance that you've done on microwave frequencies above 10 gigs?
Something like a couple 100 miles. I don't have it sitting in front of me, but it's around that kind of thing. And I've got my longest contacts on 10 gig by doing rain scatter. And in rain scatter, the 10 gig energy will actually bounce off of a thunderstorm. And so what you want to do is find one that's in between you and who you want to contact and calculate the angle that you want to point at. And Andy Flowers, he has a zero call. I can't remember his call off the top of my head. Wrote a software program that runs on Windows, and you can enter your call and the guy you want to work in your grid squares, and it'll pull up the NEXRAD radar from NOAA here in the States and show you where all the thunderstorms are and give you a suggested path to the most dense area of the thunderstorm and tell you which way to point and which way the other guy should point. And so you can both do this and work each other off of a thunderstorm system. And because it's, the thunderstorm's 20, 30, 40,000 feet in the air, it's like having a reflector that's that high in the air. So you can, by pointing up and getting away from a lot of the ground clutter, you can work stuff a long way.
Well, that's pretty amazing.
It really is neat stuff.
What's a minimal roving rig?
Well, if you want to start out on VHF contesting, you could get a inexpensive VHF radio and a decent antenna. You really want horizontal polarization for all of the weak signal modes. So if you look at if you happen to use 2-meter or UHF repeaters, you're typically going to have a vertical antenna that's vertically polarized. That's really not what you want for doing VHF roving. You want a horizontal antenna. So the two kinds people use most often are some kind of a Yagi antenna or a loop antenna. And so a very minimal VHF rover might be one that has a 6-meter loop antenna and a 2-meter loop antenna, and then a radio that would work on both those bands. And you could start out with something like a Flex 1500 or a Yaesu FT817 or something like that. Both of those radios will do sideband NCW on 2 meters. There's a lot of older radios you could pick up as well. One of the first radios I used was a Kenwood. I'm not going to be able to remember the model number of it, but there's some older Kenwood radios that are sideband radios that are still available. And they're super het that'll do sideband and CW, and those are popular with rovers as well.
Oh, pretty amazing. And they call those what, the baseband transceiver? Or I mean, how is it referred to in the architecture of a rover?
Well, if you're actually operating on 2 meters or 440, 70 centimeters, and you have a radio that works on that, you'd call it an all-mode rig or something like that because you can do CW and sideband on it. If you're operating on the microwave bands, you can't readily go out and buy a 3-gig radio. So what you do is you buy an IF radio. IF stands for intermediate frequency, and you would use a radio like one of those radios that I just mentioned, and you generate power on 2 meters or even on an HF band like 10 meters, and then you'd run a transverter which would change that frequency, multiply it up or step it up to the microwave band. Where you'd actually operate, and it has the opposite transverting side for the receiver, so it takes the microwave band and turns it into 2 meters or 10 meters or something like that. So yeah, an IF rig is what those guys would call those radios.
In your presentation at the CPAC 2018 conference, you advocated for a scientific ham radio license. I think you did anyway. How would you envision that license, and where would they operate?
Well, that kind of came out of there's almost this fear is probably too strong of a word, but a lot of the ham radio people that I talk to regularly had this belief that ham radio is going to die as a hobby. And from my perspective, ham radio is not just a fun hobby. It's also a fertile training ground for people for engineering and wireless. In my job, I run into people at other companies all the time that do radio-related things, and many of those people got their start in ham radio. So for me, the ham radio hobby is a fun hobby and thing I want to see continued for that reason, but also as a strategic thing for the United States and the world to keep a good trained group of people that understand radios and train the next generation and all that. And so one of the things I showed at CPAC was what's happening to the numbers in ham radio, and they're actually going up, not down, at least in the U.S. And so I think there's a bit of a misnomer about that, but you do see a lot of aging population in ham radio, and it's a little less common to see younger people in it. And so in order to keep that group going, keep ham radio going, I'd like to see more people that are younger that might be able to use it for other things enter the hobby. And so I was thinking about ways that we might be able to spur more people into the hobby, and one of them was some kind of a scientific ham radio license, one that would be used by people that could use ham radio more for scientific exploration as kind of another wing of the hobby, maybe people that are interested in propagation or learning about that sort of stuff that would have a different set of requirements, maybe even different call signs or something like that. And I proposed it mainly as a thing, like I said, to keep the hobby going and to get more people involved in it. I do have a sense of concern about all of our microwave frequencies, because if you look as wireless data predominantly and wireless communications grows, there's a demand for many of our microwave bands. And I really have a strong desire to keep those bands in the hobby because they do allow people to understand how those bands work and the propagation methods and all that, and train people that will become the future wireless leaders of the world. And so I want to be sure those bands are used, and I want to get as many people as I can in the hobby using those bands. So that was another impetus for suggesting something like that.
I had Dr. Ulrich Rohde, N1UL, in episode 208 of the QSO Today podcast, and he had made a point that all of the management in Rohde & Schwartz and in his company that he has in the States are ham radio operators, that he insisted that they become ham radio operators so they would understand the value of the technology. But also he said that ham radio gave us a licensed playground between DC and blue light for us to play and experiment in. And so when you mentioned the scientific license, I was actually thinking that the microwave bands, especially like the 3.5 gigahertz band, is something that probably every cellular operator would like to have. And we have it. And I see that, with the proliferation of mesh networks, that perhaps in North America, that band is probably being used more and more. But in the rest of the world, it isn't. So I think you said it, but I would advocate that your scientific licensees could actually spend a lot of time up in the microwave bands experimenting and learning.
Yeah, I really have a sense that I want science to be a huge thing in the United States in scientific education, and if I could come out with a license that got more younger people involved in playing in that playground and making use of all that. Yes, there is kind of a selfish, I don't want to lose that band as a ham, but also I don't want to lose scientific education in the U.S. and a group of trained people that understand science and understand propagation and how the different physical phenomena on different bands can be used to the advantage of civilization and all that. So, yeah, that's something I'm very passionate about.
So let me ask you a philosophical question. What do you think the purpose of ham radio is?
Well, if you go back to the charters of ham radio, I think there's 4 purposes there, and I agree with all of those. It varies from person to person kind of what ham radio is all about. As I said, for me, there's a lot of understanding physical phenomena and all that, as well as a scientific training ground for people. But it is also purely a a fun playground for people to explore and enjoy the hobby. There's people that are DXers that kind of indirectly learn about propagation and what it can do for them as a means to an end, because for them the fun of ham radio is working other people in other countries or talking to them or collecting the countries or whatever else. So I don't know that there has to be one overriding purpose of ham radio. I think it's if you look at like the national park system, you can argue that it's the same kind of thing. The national parks are there for people to enjoy for beauty. They're also there for people to fish in and for people to hike in, and every individual person derives something different from each one of those national parks that they visit. So I think ham radio can be the same kind of thing. For other people, it can be a vocation. It's something that they spend their life in, and because they enjoy ham radio and everything about it so much. So I don't think there has to be an overriding purpose to it.
I saw that you have a GitHub site on the internet, and it looks like you actually make entries and stuff into it. What do you have up there, and what are you sharing with the world on your GitHub site?
So GitHub is a place where you store software source code predominantly, and for me, I still do a lot of electrical engineering work as well as software work. Software is really a passion of mine, and I enjoy doing it. I if I get away from it for too long, I feel like I need to get back to it. So whenever I write software, I store it up there. And if you went to my public GitHub site, all you'd see are some things that I host up there that are public domain things. And so like at one point we had there was the MMTTY code, which was written by a number of different hams. A couple of them are JAs. And that source code wasn't being well maintained after a period of time, and I was a little concerned about it not being brought forward to the future and having access to it. So I offered to host that on my GitHub site. So that's up there, and there's other code that's up there, but there's a lot of code that I have on GitHub that's not even visible. That's stuff I do for Flex. So all that code's not open source, but that's what GitHub is. It's a place where we store software.
Even company software.
Yes.
I interviewed David Rowe, VK5DGR, in episode 156 of the QSO Today podcast. And in that episode, we discussed the Free Telephony Project. What is the Free Telephony Project, and how are you involved in it?
David has a history, as you probably know, in speech coding. And so there was a desire to create an open source speech codec, and a speech codec takes analog voice and turns it into digital data in a way that's not just sampled data. If you take a human voice and sample it, it consumes a lot of data. What a vocoder does is looks at the individual syllables and sounds that people make and turns those into data, and so it yields a much higher compression rate than you would just sampling the human voice digitally. And so David wanted to use some of his education and scientific background to create one of those and make it open for people to use and make it a standard across ham radio. And when he did that, and I was at a Tucson Amateur Packet Radio, a TAPR DCC conference, and saw that software in work and got excited about it and thought this is something that really needs to be carried forward in the hobby. And I was concerned that it was only going to be embraced by the open source community and wouldn't show up on other commercial ham radios, which is really what I felt like it needed to succeed. And so at Flex, I convinced the guys at Flex that we really needed to adopt FreeDV, or Codec 2 as it's called, and put those into our radio and make them available as another form of communication in the radio. And so I got, for that project, I actually got some students at a local university that were doing a senior design project that's required in all engineering disciplines. You have to do a capstone project. And I got them to help us port the code from Codec 2 and make it run in the radio along with some of the engineers at Flex. And so we do host that code up on GitHub and make that available for other people to go use. And in fact, you could go take that code that we have up there and write your own speech codec if you wanted to and make it run on any Flex radio. And part of the reason, another thing that reason I did that was when I was in college, the first radio I ever bought that I spent real money on was a Kenwood TM721A, which is a dual band FM VHF UHF radio, and it kind of tickled my interest in a couple of ways. One was I was doing a lot of VHF and UHF repeater kind of communications to local friends, and the radio accomplished that. But I also have a real interest in interesting display technology and ways of representing what's going on in the band. And so it was the first radio I'd ever seen that used a kind of color backlit LCD display. And so I was fascinated by the display technology in it. So I bought that radio and used it in college. But I remember being frustrated that I couldn't go program the radio to do the things that I wanted myself. And so when I ended up at Flex, I wanted to make the radio something that people could interact with at a software level and write their own programs to make the radio do things that they wanted. So Codec 2 is part of that. The Smart SDR API is another part of that. So we have a wiki at Flex Radio, wiki.flexradio.com, which details the Smart SDR API or Application Programming Interface. And we use it to drive the radio from Smart SDR that you see on a PC. So all the things that we do to make the radio run, you can do. You can go write software to make the radio do any of the things that we do with it. And that, again, stems from my desire to have done that when I was a young engineer, young college student, and was unable to do that on other ham radio equipment.
What kind of impact has amateur radio had on your family life?
Well, I'm married. I have a wife and 3 kids, and I did a little bit of ham radio when I was in college, and that's where I met my wife. And so she was aware that I did some of that kind of stuff, but she never really had much interest in it herself. And for her, it's been something that I did kind of on my own when I did stuff. But once I had kids, the kids expressed interest in it in varying degrees, and so I did some ham radio stuff with the kids. My son, when he was 8, I kind of saw that he was ready to express a little bit of interest in it, and I talked to him about it some, and he was kind of interested in what Dad did on the radio and some of that stuff, and kind of not interested in it. And so we talked about it on and off, but never really could get him interested in it until we went to Dayton one year. And we went to Dayton when he was 8, and I took him to the ARL booth, and he visited with some people there. They had a kids demonstration there, and it was Andrea Hartledge, I think. Trying to remember her call. It was a 4 call. I think it was KG4 UGM or something like that. And he met her there, and she was controlling some kind of remote control device, like a little car. And I assume that the device they were using used ham radio. And he was really fascinated by it. And I said, well, do you want to stay here for a while? You know where I'll be. And he said, sure. So he hung out in the ARL booth for, 30 minutes or an hour, and then came back and, kind of did the tug on the shirt thing and said, hey, Dad, he says, I want to get my ham radio license. And I said, well, sure, that's great. Yeah, we could do that. And he says, no, he says, I want to get it now. And I said, what do you mean? He said, well, how do I do it? And I said, well, you need to go get a book and we'll study. He says, well, where are the books? And it was like a switch had been turned on. And so he got really interested in it real quick and got his license then when he was 8. And then he started roving with me and doing 6 meters. When I started doing my early microwave roving, my roving partner was Jim Reese, WD5IYT, who was also one of the guys that I learned from a lot, VHF, UHF stuff in college. And he would sit up front with me, and Jim always said he had to be driving because he was either driving or puking. He couldn't ride in a car as a passenger. So I would operate, Jim would drive, and my son Ryan would sit in the back seat with a Flex 3000 and work 6 meters while we worked microwave stuff in the front. And I explained to my son how multipliers worked, and he would sit back there and work contact after contact after contact on 6 meters and announce every time he had a multiplier. And we kind of were demoralized in the front seat because we'd work, a contact or two every 10 minutes or something, and he was back there, chalking off contacts every couple of seconds. So then I have a couple of daughters, and my daughters never really have been interested in it. One of my daughters got interested briefly, but it's just not been something they're terribly interested in. So, we used ham radio. My son and I, when we'd go on vacation, we'd use handy talkies to talk between groups of the family when we're separated and things like that. But, and of course I ended up in a career in ham radio.
You made a comment, I think, in your presentation at the beginning that you took your children to school in the rover, and the kids seem to be sensitive about how their friends perceive them. Did their friends or did your children have any issues with you delivering them to school in the rover?
No, it's funny. My kids now are 21, 19, and 16, so they're older now. And when I was doing the rover, they were about 10 years younger, and so you can imagine they would be in middle school, that kind of thing at that time, or late elementary school. And so in that time frame, getting delivered in something that looked like a Ghostbuster vehicle was not a big deal. In fact, it was a source of conversation and everything for the kids. So for the most part, it wasn't anything that bothered them at all. When they got older, it was a little bit more of a deal, but I don't think any of them really got teased about it or anything. I think it was more, hey, what is that, and how does that work, and what's up with that?
What excites you the most about what's happening in ham radio now?
Gosh, there's so many things. I'm really interested in digital modes and that sort of thing. I'm very, very excited about the prospects for a geosynchronous asymmetric satellite. There's a project going on called Phase 4 Ground. Michelle Thompson and a large group of other people that understand satellite technology and the demodulation required for that sort of thing are off working on that project. And I'm very, very fascinated in that and the prospects of what that could be. Very briefly, the idea is to put a geosynchronous satellite in orbit and use asymmetric communication. So you'd use some sort of narrowband to go up to the satellite, and the satellite would transmit wideband like DVB modulation down to the ground. That's extremely fascinating to me. I would love to work full-time on software for the satellite or ground station on a project like that. And that project kind of tends to get an on-again, off-again role just because the thing that's the big key to it is getting a ride to space. And if you have to pay for a ride to space, it's millions of dollars. And so it's all about, can you fundraise enough or hitch a ride or whatever to get up into space. But that project's very, very fascinating to me. I'm very interested in all the things I think we can do moving forward in talking on the microwave bands and spectrum analysis and digital decoding and all those kind of things. If you look at the cellular and wireless industry, they've driven a huge amount of technology that hams can take advantage of. There is a synergy between ham radio and either government or commercial communications, in that there's things that get done in ham radio that get taken up by the commercial world. Like you look at AX.25, packet radio ended up being used a lot in the commercial world over time. And so a lot of the components that have been driven by the cellular industry, everything from analog to digital converters to microwave mixers and power parts that generate power at 3 gig, 5 gig, 10 gig, all those things have been driven by the commercial and military markets. And so those are opening up a whole new group of things that we can do on the microwave bands. As time moves forward, I think you'll see more and more equipment in those parts of the band. So a lot of that stuff's really exciting to me.
At prices that are through the floor because of their prolific nature in cellular phones, for example.
Yes, there's components that, like you look on the microwave oscillator that I have a gain block on there, and it uses an Avago chip that Al Ward, W5LUA, recommended to me. And when I looked at that chip, it's a little teeny part, and the part costs like 50 cents. And it's a good, I think it's a 20 dB gain block. And if you had to do that before the advent of cellular, it would be significantly larger and more expensive to go get a part like that. And yeah, so the cellular industry, a lot of the guys that are building parts for that industry, for them a design win is to put a very small part that does a lot of stuff into a few million cell phones. And so if you're going to put a part into a million devices, it needs to be low cost. And so that low cost, as hams, we get to realize and put those same parts into our equipment. That's a really huge deal.
Yeah, I believe it. What advice would you give to new or returning hams to the hobby?
Well, I think my advice always to any ham is to have fun and do things that really drive your enjoyment and knowledge in the hobby, and that's what I've always done in it. I do like to encourage people to get back to the hobby, and Elm or others. It is a hobby that on the surface can seem daunting. Like if you look at the hobby of photography or astronomy, anybody can go out and buy a camera, point it at something and take a picture, or set up a telescope and look at it. And it's not, the hurdle to get into those hobbies isn't too high. To get into ham radio, there's a lot more stuff. You look at the wide array of equipment that's available and the technology and how it works and what you need to know to get in the hobby. There's kind of a hurdle that you have to get over there. So I would encourage anybody that's been in the hobby and shares my excitement in it to go mentor people in it and get involved in a local club and help people to enjoy the hobby.
Well, Steve, you've been a terrific guest and quite articulate in your positions, and I really appreciate your taking time with me today. We've had a number of power failures this afternoon at the 4Z1UG QTH, which means that Stephen and I had to start and stop over again a few times. With that, I want to thank you and wish you 73.
Okay, thanks very much, Eric. I've enjoyed being on. 7-3.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Steve. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in N5AC in the search box at the top of the page. My thanks to both ICOM America and QRP Labs for their support of the QSO Today podcast. Please show your support of these fine sponsors by clicking on their links in the show notes pages, or when you make your purchases, that you say that you heard it here on QSO Today. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the other episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes page. I am grateful for any way that you show appreciation and support. It makes a big difference. QSO Today is now available on iHeartRadio, Spotify, Libsyn, and TuneIn, as well as the iTunes Store. If you own an Amazon Echo, you can say, "Beep, play the QSO Today podcast from TuneIn." I still use Stitcher to listen to podcasts on my smartphone. The links to all of these services are on the show notes pages on the right side. Until next time, this is Eric 4Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.